All right, good morning or good afternoon, everybody, whenever you're watching this video. Sorry it had to come to this, but the Wi-Fi and the Ethernet on MSU's campus is not working for me right now. So I decided just to make it easy, instead of the Wi-Fi cutting in and out during lecture and the live stream, I would just make kind of a video today, kind of introducing you to this class, and then going over the first couple of sections that we're going to be covering in Chapter 10. So if you're watching this video, you are enrolled in my winter session Synchronous Online Calculus 3 course. So normally after today, we will be meeting live on WebEx through Canvas from 10 a.m. to sometimes 11:50, but very rarely will we go the whole time. Today, like I said, it's just going to be a video. It won't be near as long, but I did still want to provide you with some information just so you are aware of how this class is going to be set up and what you're expected to be able to do. So before we get into the lecture videos, what I want to do here is I want to kind of go through the syllabus and the Canvas page and all that good stuff. So if you give me 1 second, let me pull up y'all's syllabus on my OneDrive. So give me just 1 second. Let's see, Cal 3, winter session, syllabus. So I'm going to go through this pretty quickly because it's already posted on Canvas for y'all to see. But like you said, as you can see, the prereq for this course is a C or better in Calculus 2. If you don't have that, it probably already kicked those people out of the class. But if you're in the class still, you're probably okay. We are currently using the Thomas Early Transcendental Calculus book. While we don't use the textbook per se in my class, you do have to get access to MyLabs Math, which I'll go over that in just a second. As some of y'all are aware, we still have Bulldog Bundle, so some of y'all may have opted into Bulldog Bundle. Some of y'all may not have. We're going to go over both situations here in just a minute. Either way, everybody's going to have to get integrated through MyLabs Math in Canvas because that's where all of your homework and review quizzes will be, which is a good chunk of your grade, as you'll see in just a second. Throughout this winter session, you see my email address right there at the middle of the screen. Please make sure you spell my name correctly when you email me. You can also email me through Canvas. Just know that I don't check my Canvas email as much as my regular email. So if you do email me through Canvas, you may not get an immediate response, but I will do my best to check that at least once a day. So as you can see here, throughout this month of December and 1st of January, you will have 11 homework assignments. We will be covering entirely Chapter 10, 11, 12, and 13 in the calculus book. So you'll have 11 homeworks throughout the winter term. There are only 2 tests in this class because since it's such a quick-paced course, I don't do traditional tests like I normally would do in a regular Cal 3 class. So instead, I'm going to do just a midterm and a final. Those will not be cumulative. Instead, I'm going to take the first 2 chapters, chapters 10 and 11. That will be your midterm exam. Chapter 12 and 13, that stuff will cover your final exam. And like I said, they will not be cumulative. In the final exam, you just got to do the last 2 chapters. Before each of those tests, you will have a review assignment you have to do. It is kind of long, and it does count for a grade, but it will prepare you for the questions that you're going to see on those exams. So there are only 2 of them, and we'll talk a little bit more about those as we get closer to the midterm exam, which is after Christmas. You can see there's not a lot of grades in this class. The homework, I'm a big advocate for people doing their homework and it helping them out. As you can see, your homework is going to be 30% of your final grade, so do your homework. You get unlimited attempts. That should be an easy 30%. The review assignments, both of them combined will be 10% of your grade. And then the midterm and the final each will be 30% of your grade. So not a whole lot of graded assignments because it's such a short course. But you do have to make sure you do well so that you can pass this course. You'll see right here on the midterm and the final exam, more information about that. I'll allow y'all to read through that on your own. But just note that the calendar that I'm going to show in just a minute has the dates of the midterm and the final. And so those are the days you have to take those exams, no exceptions, because this is technically a synchronous online class. The one thing I will mention in this little paragraph here is that since this is going to be a show your work assignment, how the exams will work is you will have questions in front of you when you open up the test on Canvas, and then you will actually work the problems on your own paper. That being said, in order to submit your work, you're going to have some kind of PDF converter. There's some that are already built into smartphones like Androids and iPhones. You can actually use a traditional scanner if that's what you prefer to do. You just need to have a way to convert your work that you do for the exams into a PDF, because you will have to submit a PDF into Canvas for grading. I'm not going to grade a JPEG file or anything like that. It needs to be a PDF so that I can mark on it and be able to give you feedback to what you messed up on, or kind of encouragement of whatever needs to happen. I know you're watching a video for the first day's lectures, but starting tomorrow, December 14th, you will traditionally enter class this way, so you can read through that. As I told y'all in the intro email, I am not doing videos for this class because last winter I had a number of students who quit coming to class and just wanted to watch the videos and treat this more like an asynchronous class. This is a synchronous class, so instead of posting videos, the only thing I'm going to post is the worked notes that I do in class each day. Today will be an exception. You will have this video posted because it's not y'all's fault. The Wi-Fi is out on campus. Excuse me. But going forward, you will only have the posted work notes. There won't be any explanations on them. That's why you need to come to class. I will kind of virtually take roll. I'm not going to report roll anywhere because I don't worry about that. But will keep a record of who comes to class each day, just for my own personal information, just so I kind of know who's coming to class, who's participating, in case anything needs to be decided about grades at the end of the semester. As of right now, I originally planned to use HonorLock, so I'm going to have to update my syllabus a little bit. Originally, they told us we were going to be able to use HonorLock for this class, but it seems that since this is not a Campus 5 class, that HonorLock is not an option, so that might be good news for some of y'all. So we're not going to actually be using HonorLock in this class, so you can ignore this part of the syllabus, but I got to figure out a way how we're going to do this, so I'll update y'all more information once I figure out Plan B. When it comes to not HonorLock, but to how tests are going to be proctored and such. But the thing I mentioned earlier about converting your work to PDFs, that still holds, but the HonorLock part is not going to be part of that. Like I said, y'all can read through the rest of this. Ignore all the HonorLock stuff. But there you go. That's kind of the syllabus. You can read through all of that again if you would like. The second thing I want to go over, let me get this part of OneDrive, is the calendar. So also on Canvas is a sample calendar. So what you will see is that on this calendar, everything in black is the sections that I plan on covering that day. So in just a minute, the video will start and cover sections 10.1 and 10.2. Tomorrow we'll do 10.3, 10.4, etc. Everything in green is your homework assignments, and where you see the homework listed, that is the date that the homework is due at 11:59 p.m. that night. So for example, the two sections that I covered today, that homework assignment is going to be due on Thursday night, the 15th. So you'll have to get registered for MyLabs Math, which I'll show you that information in just a minute. Get registered for MyLabs Math, and you need to get that homework assignment done by then. I do my best to try to give you a day or two to get the homework assignments done, but note that this is a 4-week course, so things are due a lot quicker than a traditional class. So just keep that in mind as you're taking this course. Mississippi State is requiring us to give y'all the 21st through the 23rd off, so there will be no classes that day. And then due to traveling by me as well, we will also not have class on the 26th of December. I know it's a class day set by MSU, but since I will not be able to have class that day, I'm just going to give you all the day off. So note that. You'll also note that the midterm exam is scheduled for December 29th. We'll talk more about that as we get closer to the midterm. And then your final exam, which that day is set by Mississippi State, is going to be on January 13th. So make sure you note that as well. Like I said, we'll talk more about those as we get closer. So now, finally, before we start lecture, moving into the Canvas page. So I'm sure some of y'all, probably this morning, if you didn't see my email, tried to come through here to get into the live stream. Good try, but unfortunately, I couldn't get it open this morning. But a couple of things I wanted you to note is that starting tomorrow, as you can see over here on the left-hand side, there's a tab that says Cisco WebEx. So starting tomorrow, you will click on Cisco WebEx. All right, sorry, I'm on my iPad, so I'll have to enable it. All of mine say start. because I'm actually going to start the lectures each days. I believe y'all's will say join. So you will click on join, but it won't say join until actually I start the live stream. So I will try to get the live stream up about 9:50 each morning. So at that point, you'll be able to join the lecture, and then it'll be kind of like a regular class, only online instead. Outside of the WebEx module, the other modules, if you're a person who likes to kind of have their notes open ahead of time to see what's coming up, you'll see all of my blank notes are in here. I will also be uploading the work notes after I actually teach the sections each time. So I'll create a new module that says work notes as well. Your exams will be in here. I haven't uploaded them yet, so you won't see any exams currently, but that's where the exams will be, and we'll talk more about that closer to that time. The syllabus and the calendar that I mentioned are right here, so you're good to find those there. Sorry about that, y'all. Have a little cough this morning. The last thing I want to show y'all, and I've already gotten an email or two about it this morning, but I've kind of ignored it because I wanted to make sure that I did it in the video, is that you have to be able to register for MyLabs Math. Now, I'm going to turn on Student View, and hopefully this works out nice on my iPad, but no guarantees. So when you log in and you want to get registered for MyLabs Math, which was required for everybody, if you took Calculus 2 here at Mississippi State this past semester, you should be used to this. But what y'all will notice is that there is a MyLab and Mastering link on the left. That is how you will actually have to register. Now, one thing I will notice is down here at the very bottom, there's a tab that says Bulldog Bundle Digital Materials. If you click on that, now some of y'all may have opted into Bulldog Bundle and some of y'all may not have. If you opted into Bulldog Bundle, and I'm going to say this again because we had a lot of problems with this in the fall. If you opted in or stayed opted into Bulldog Bundle, this is where you can go to get your access code. You can hit reveal access code. Now, obviously, I do not have one because I'm not a student in this course, but your code will be right here that you can either copy into your digital sync or you can write it down if you would like. If you opted out of Bulldog Bundle, do not use this code. We had a number of students who did that and got kicked out of MyLabs Math, and it took a couple days to get them back in. In a winter session course, missing access for a couple of days will have you miss multiple assignments. And I'm not going to reopen assignments because you tried to use a code that you don't want to pay for. So do not use this code here unless you are opted into Bulldog Bundle. If after that, everybody will go into the MyLab and Mastering link. All right. Now, I probably can't do this on my iPad, so I'm not going to go much further. But essentially, you will click Open MyLab and Mastering, and you will follow the instructions to get registered. I believe, let me pull my syllabus back up on OneDrive. If you go to the very end, oh, I didn't put it on here. I will post the information of how to get registered for MyLabs Math on Canvas. I was going to go over this a little bit later or in class live stream, but I guess that's not going to work here. But you'll need to go through the information of getting registered. Like I said, if you took calculus here this past semester, it's the exact same thing. You may be able to figure it out on your own. If not, I'll post the information of how to get registered. When you're going through the registration process, obviously, if you're using Bulldog Bundle, that code that you have copied already or written down, you'll use that to type in. If you're a person who opted out, remember, do not use that access code. Instead, you will have to either purchase the access yourself. And you can buy an access code from a different site if you'd like. I wouldn't trust that, but that's obviously an option if you can find one that's legitimate. There is a temporary access in there as well. The temporary access is only good for 2 weeks, so it will not cover the entire winter session course. So you need to make that decision on your own. If you have any particular questions about payment and stuff, you can send me an email. I don't discuss that in person because other students are listening, but I'm more than happy to answer those via email when it's just me and you as the student talking about it. So please get registered as soon as possible because like you saw, your first homework assignment is due 2 days from now on Thursday night, and we'll be over the sections that I'm covering today. All right, let me leave student view so it doesn't mess me up later. And that being said, that was a kind of a good 15-minute introduction. What I'm going to do now is I am going to cover the first 2 sections of Chapter 10. So As you saw earlier, your midterm will cover chapters 10 and 11. They are a little bit different chapter-wise. They don't really kind of go with each other, but they are two chapters you have to know how to do. Chapter 10 is all about the idea of infinite sequences for a little bit, and then we're going to primarily focus on infinite series. My goal today, it won't be too long of a video at this point, is to kind of give you an introduction of what we're going to have here. All right, so we're going to start in section 10.1, which is sequences. And let's talk about what sequences are. All right, so a sequence can be thought of as a list of numbers that are written in a definite order. So how we will note sequences in this class is we will see them listed in some kind of order. We usually call them A1, A2, A3, etc., etc. The difference is that these numbers, however they're listed, are listed using some kind of pattern to dictate their order. Now, actually writing out each and every term is going to be a little bit kind of a waste of time. We don't want to write out every single number. That won't help us. So traditionally what we will do is we will write our sequences in one of these two compact forms. We will either use the squiggle braces with A sub n, or we can use a little bit more of a formal notation, which is A sub n, where we're going to start at n equals 1, and we will end at infinity. Remember, we're going to eventually call these infinite sequences, so there's going to be infinitely many terms in this sequence. This A sub n that you see inside the squiggle braces, that is the expression that dictates the pattern. And we're going to have to write our own here in a few minutes. But to start off, I want to give you a few patterns, and we're going to learn how to generate the numbers ourselves. So for example, I want you to list the first three terms of the following two sequences starting at n equals 1. So on part A sub n is equal to 1 minus n over n squared. So if you want to find A sub 1, all you are doing is, since you're replacing this n with 1, you need to replace every n in the problem with 1. So that would be 1 minus 1 over 1 squared. And at this point, use whatever calculator you'd like, because it's just going to be used for basic arithmetic anyways. If you type this into your calculator, you should get an answer of 0. And we're going to continue this for however many terms they'd like us to. So they want us to go to 3, so I'm going to find A sub 2 next. So change all your n's to 2's. 1 minus 2 over 2 squared. So that's going to be a negative 1 on top and a 4 on the bottom. So that's negative 1/4. And finally, A sub 3, which would be 1 minus 3 over 3 squared, which is negative 2 over 9. And so that's a very traditional sequence that you can find as many numbers as you would like pretty quickly by just kind of plugging in and simplifying. Part B is going to be our first one where the sequence is a little bit different, and we're going to find all of our numbers, and then we're going to talk about a couple of things as well. So the next one is A sub n equals negative 1 to the raised to the n plus 1 over 2n minus 1. So when you go to find A sub 1 this time, it would be negative 1 to the 1 plus 1 over 2 times 1 minus 1. So let's see. That would be negative 1 squared on top, which is just positive 1. And then 2 times 1 minus 1 is 1. So you get a value of 1. Okay, that's not too bad. A sub 2 would be negative 1 to the 2 plus 1 over 2 times 2 minus 1. So this would end up being negative 1 to the third, which is negative 1, over 4 minus 1, which is 3. And finally, A sub 3 is going to be negative 1 to the 3 plus 1 over 2 times 3 minus 1. All right, so that would be negative 1 to the fourth, which is positive 1, and then 6 minus 1 is 5. So what you're probably noticing is those numbers weren't hard to find. I agree with that. But what I want you to notice here is that this negative 1 to the n plus 1 on top, that's very important that we're going to see in just a minute. When that occurs, what you will notice happens is that every single number, while it doesn't dictate the values that we were getting, what ends up happening is you end up getting what we're going to call alternating terms. So when these terms alternate, that only occurs when there is a -1 raised to a particular power. Now, -1 to the n plus 1 is a very popular one, all right? So you'll see that one from time to time. Two other alternating terms that you will see, first is -1 to the n minus 1. Now, these two right here are interchangeable because both of those will have you always start at a positive number. So if your alternating term wants to begin with a positive value, you have to use one of these two. But what if you want your alternating terms to begin with a negative number? It's slightly different. You will use -1 raised to just the power of n. And this will guarantee that your first term in the sequence will be a negative value. So there's two different kinds of sequences. We can find the numbers just fine. And then the other kind of sequence that we will see a little bit of is what we call a recursive sequence. So this one plays a bigger role because we can't just jump around. Instead, we will have to do these in a particular order to get our final answer. So the example says, list the first 5 terms of the recursive sequence defined below, starting at n equals 1. So this time it's telling us that a sub 1 is -2 and a sub n plus 1 is n times a sub n over n plus 1. So a little good news, bad news here. The good news is that the first term is probably the easiest part of this. A sub 1, they have given us, that is -2. Where you have to now be careful is that when you go to find your next term, which is a sub 2, I did not give you a sub 2, but we did give you an expression to help us find that. So what you will notice is that you're trying to make the subscript of this particular a be a 2. That's only going to happen if that n value is a 1, because 1 plus 1 would be 2. But if that n's going to be a 1, then every n in the other side of the expression has to also be a 1. So this would end up being 1 times a sub 1 over 1 plus 1. And then a sub 1 is what was defined a minute ago. That would be 1 times -2 over 1 plus 1, which is -2 over 2, which is -1. So there's your a sub 2. And now you're going to continue this pattern until you find the first 5 terms of a. So a sub 3. Going back to our definition, your n value now has to be a 2 because 2 plus 1 would be 3, which means in our expression, every single n has to be a 2 this time. So if we plug in what we know, this would be 2 times -1, because that's a sub 2, over 2 plus 1 is 3. Simplifying that, you get -2/3. All right, keep going. A sub 4. This would now be 3 times a sub 3 over 3 plus 1, which will end up being 3 times -2/3. 3 plus 1 is 4. Multiplying 3 times -2/3 is going to give us -2 over 4. And then that's going to simplify into, not that, -1/2. We're going to room a little bit here, so come up here to the right. Finally, a sub 5, following the same pattern for the fourth time in a row. This will be 4 times a sub 4 over 4 plus 1, which will end up being 4 times -1/2 over 5, which comes out to be -2 over 5 for a sub 5. So this one is a little bit more time consuming because, as you can see, you can't jump around from term to term because each term is dependent on what you found previously. Unlike the first slide that we did up here, I didn't have to find these in order. I could have jumped around and found any of these at any point. These are non-recursive sequences, where this example here is what we call recursive. All right, I mentioned a little bit earlier that sometimes you have to write your own sequence, and we will also see this throughout chapter 10. So here's kind of our first little taste of this, and you watching me do it on the stream. So the example says, find a formula for the general a sub n of the sequence, assuming that the pattern of the first few terms continues. We're going to assume that you start with n equals 1. Now, remember, at any point during this video, if you want to pause and try any of these problems on your own before you watch me do them, you can do that. For example, if you want to try to create your own patterns here, pause the video for a second and see if you can write your own patterns, and then you can unpause me and see how I would go about finding these patterns. On part A, I see that the terms are 0, 3, 8, 15, 24. Now, many things may be going through your mind here, and some of them may lead down a possible path, but you may run into a dead end trying to write a general expression. What I notice about all of these is that each one of them is one less than a popular number that we are used to. Do you know what it is? It's the squared values. So you've probably learned throughout your math life that squared values are 1 squared is 1, 2 squared is 4, 3 squared is 8, or 9, 4 squared is 16, etc. All of these numbers are one less than if you were to square the numbers yourself. So if that's the case, I can think of a sub n as being my n values squared, and then I'm going to take each of those values and subtract 1. Because then do the first couple in your head. 1 squared minus 1 is 0. 2 squared minus 1 is 3. 3 squared minus 1 is 8, and so on. So this would be your expression. On part B, you have 1, negative 1/4, 1/9, negative 1/16, and 1/25. First thing I actually notice about this one is something we talked about a little bit earlier in this video, is that all of these terms are alternating. Well, that's okay. If you ever see the terms alternating, remember, that's going to bring back that negative 1 raised to a particular power in this case. Now, since the first power or the first term is positive, it's a positive 1, that means you either have to use the n minus 1 power or the n plus 1 power. I usually stick with n minus 1, but it doesn't really matter. You could also do n plus 1 here. I am then going to multiply this by, and then I'm going to figure out what's generating all of the numbers. Remember, this negative 1 to the n minus 1 is taking care of your alternating terms. If I'm looking at just the numbers, so if I'm looking at just the 1, the 1/4, the 1/9, the 1/16, and the 1/25, I notice that each and every one of them has a 1 on top. So that's good. And then on the bottom, it looks like, similar to part A, that each term is just being squared starting with n equals 1. So on the bottom, I would write that as n squared, because then that would be 1 divided by 1 squared, 1 divided by 2 squared, and so on. Now, traditionally, we don't leave these terms separately. If we were to multiply them together now that we're done, this would be negative 1 to the n minus 1 on top and n squared on the bottom. And then that would be your expression that generates this particular sequence. All right, and then to wrap up the first section I have planned for today, we need to go over one last topic with sequences. The big idea that we're going to get into through most of chapter 10 is all about the idea of convergence and divergence. So in this example, how do we know if a sequence of numbers, an infinite sequence of numbers, I should be more particular, does it converge or diverge? So I'm going to read the whole definition here for you. Some of it may not make much sense, but I'll kind of wrap it all together at the end. It says the sequence a sub n converges to the number L if for every positive number epsilon, there corresponds an integer capital N such that the following inequalities are true. If no such number L exists, then we say that A sub n must diverge. So that may sound a little confusing reading the formal definition. Let's see if this helps. If your sequence converges to L, then the following must be true. We're going to go back to Cal 1 class for a minute, and we're going to take the infinite limit of our A sub n expression. Okay? If you can take the infinite limit and get a value L, then it converges. But if L is equal to plus or minus infinity, or it does not exist. Remember back when you learned about limits in Calculus 1, some limits do not exist. If this is the case, that is when you can say that your sequence will diverge. So it's going to be kind of a play on a bunch of Cal 1 problems here for a second, but we're going to actually add an extra line at the end of what it means after you take your infinite limit. So for example, on part A, determine if the following sequence converges or diverges, and just explain really quickly why. A sub n is 1 minus 5n to the fourth over n to the fourth plus 8n cubed. Since this is a sequence, the only thing we ever have to do to determine if a sequence converges is to take the infinite limit of 1 minus 5n to the fourth over n to the fourth plus 8n cubed. And then, as you probably remember from Calculus 1, is that when you take an infinite limit, if the highest power on top and bottom match, which in this case they do, n to the fourth and n to the fourth, you use the ratio of coefficients. So in this case, your answer would be -5. Since this is a number, and it's not infinity, it's not negative infinity, and it's not D and E, this means that your sequence converges. Sorry for the bad handwriting there a little bit. I don't need a full-on paragraph about explaining why. As long as you show me the reason why, which is showing me the infinite limit, that's enough to show me that it converges. Let's look at part B. A sub n is the square root of 2n over n plus 1. So once again, if I go to take the infinite limit of the square root of 2n over n plus 1, once again, the highest power on top and bottom is exactly the same. They both have an n on top. So if you use the ratio of coefficients, that's going to give you an answer of 2. But since this ratio is inside of a square root already, you have to leave your final answer value inside of a square root. So the actual value of this infinite limit would be root 2. Once again, that is a number that you can find. So just by showing me that, this means the sequence also converges. And sometimes they are that straightforward, but you have to remember your limit rules from Cal 1. Let's do 2 or 3 more to wrap up this first section. Part C. What if A sub n is 2n plus 1 over 1 minus 3 root n? Once again, same idea. It's a sequence and you're trying to determine if it converges or not. So I'm going to come right below and I'm going to do the infinite limit of 2n plus 1 over 1 minus 3 root n. The difference this time is that if you look at your highest powers, the highest power on top is actually bigger than the highest power on the bottom. All right? If that's the case, then that tells me immediately that my answer is either positive or negative infinity. If the power on top is bigger, it's got to be one of the infinite values. How I would figure that out is I would just kind of eyeball what's going on the top and bottom. If you were to plug infinity into the top, this would give you a positive number because 2 times infinity plus 1 is a positive number. But if you were to plug it in the bottom, 1 minus 3 root infinity would actually end up becoming a negative value. And as y'all have learned from many classes, a positive number divided by a negative number means your answer is just going to be negative infinity. That's an answer that we really don't want to see when we talk about convergence. So if you do get an infinite value, that's fine. That just means that the original sequence, it diverges. Now, occasionally you will have to deal with trig. There's not a whole lot of trig in chapter 10, but we will see a good bit of trig later on in this course. So make sure you're comfortable with that. What if it's a sub n equals the sine of pi over 2 plus 1 over n? Well, if you take the infinite limit of the sine of pi over 2 plus 1 over n. Now, the pi over 2 is not going to do anything because that's just a number. What you're focused on is what's going to happen when you plug infinity into the 1 over n. So for the last shortcut rule, as a reminder, if the power on the bottom is bigger, which in this case, the only power you have is on the bottom. If the power on the bottom is bigger, then this whole expression here goes to 0. And if just that piece goes to 0, this becomes the sine of pi over 2, which from trig class, you should remember that that is an answer of 1. Since that is a number that you can find, that means your final answer for this one is that the sequence converges. Once again, on the explain why, I don't need a lot of words. I just need you to show me the work and then give me the answer to the question at the end. I'm more checking, are you doing the enough math to verify your answer? All right, and then to wrap up section 10.1, we're going to do one that requires a couple extra steps to find whether it converges or diverges. So for part E, if a sub n is the natural log of n plus 1 over the square root of n, how would you go about doing this one? Well, first step is the same. You're still going to take the infinite limit of the natural log of n plus 1 over the square root of n. When you go to plug infinity into this, there is no shortcut rule because the natural log is throwing you off there. But when you plug infinity in, the natural log of infinity is infinity. On the bottom, the square root of infinity is infinity. And so what you probably remember from Cal 1 is that when you get infinity over infinity, this is one of your indeterminate forms, which means the easiest way to fix this is you're going to go back and use the rule that you learned called L'Hopital's rule. L'Hopital's rule is a way that you can solve for an indeterminate limit of this form. So thus, your limit as n approaches infinity is going to remain the same. Remember, L'Hopital's rule tells you that you can take the derivative of the top and the bottom separately, and then that way you can go from there. So, for example, the derivative of the ln of n plus 1 from Cal 1 would be 1 over n plus 1. Root n, remember, that's n to the 1/2. So if you take the derivative of that, it would be 1/2 n to the negative 1/2. I'm going to clean this up a little bit to make my life a little easier. So I'm going to write this as the limit as n approaches infinity of 1 over n plus 1 divided by, and this would be 1 over 2 n to the 1/2. I'm just going to move the negative exponent on the bottom. I'm doing that because over here, now that I have a fraction divided by a fraction, I remember from algebra class that I can do keep, change, flip. And I can leave this as 1 over n plus 1 times the reciprocal of the bottom, which would become 2n to the 1/2 divided by 1. Now, if you were to put these together, and we're almost done with this problem, your new fraction now becomes 2n to the 1/2 divided by n plus 1. And now back to your shortcut rules. Since the power on the bottom is bigger than the power on top, I know that this limit will go to 0. That is an answer that we can get. That's fine. That means that your sequence converges. And so as long as you don't get an answer of positive or negative infinity or D and E, which we didn't do any D and E examples today, that means your sequence will converge. If you do get infinity or negative infinity or D and E, I guess, then your answer would be divergent. And so that ends section 10.1. So if you need to pause the video now and take a mental break before you do the next section, that's great. But I am going to go ahead and move on into section 10.2, which is going to be the start of what most of the rest of chapter 10 is about. We're going to do section 10.2, which is an introduction to infinite series. Now, sequences is what we just covered in the first part of this video, but series is what's more important for a lot of y'all as you move on into probably other disciplines or other classes that might need this. So what I want to do for the rest of this video is I'm going to do a brief introduction to what a series is. We're going to go over a couple of basic series that were very easy to work with, and then that's where I'll end the video. And then I'll talk more about at the end of this video what tomorrow's class is going to entail. All right, so what is a series? So if you just want to kind of listen for a minute, or if you